name of God. In the name of God, we started the first session of Advanced Thermodynamics. Okay. Before we started the Advanced Thermodynamics course, we have a review on basics of thermodynamics that you are familiar with it in the BA courses. I put the lecture of this session in the LMS site. Okay. We first start with concept and definition. We have two categories of study in the thermodynamics. The first is control mass and the second is control volume. The difference between control mass and control volume is that in the first control volume, control mass, we have no inlet and outlet of mass. So the boundary of the system is isolated to the mass, but you can have a heat and power work with this control mass, but you can't have a inlet and outlet of mass. In the control volume, inlet and outlet of mass exists in the system. If you see in the picture, we have a compressor. Compressor is a device that converts electrical power to increase pressure of the system. You see it in the control volume, air with low pressure input to the system and with high pressure outlet of the system. So the mass is enter to the system and exits from the control volume. We both have an inlet and outlet, but they are equal in the steady state process. Means that the mass of the mass flow rate of inlet air is equal to mass of the air that exits from the control volume. But you can have work and heat in interface of system. In control mass, like the cylinder and piston that you can see in the upper picture, the boundary of the system has only work and heat in interface with environment. No inlet and no outlet of mass. The mass of the system is fixed and we have no inlet and outlet of system. The other, we have some definition that is important in thermodynamics. First is a specific volume. A specific volume is defined as the volume per unit mass. That denoted was by Greek letter nu. The other definition is phase. Phase is defined as a quantity of matter that is homogeneous. Homogeneous means in all the system we have the same chemical formula for the matter. But The phase of when we define the phase of the system, you can have in material in more than one phase. For example, liquid or vapor or solid. It is they are the some phases of material. The other definition is a state. A state is defined as is a microscopic property. So when we talk about a state, means that quantity of for example, temperature, pressure, density, there are a state of the system. Thermodynamics property is divided in two general classes, intensive and extensive. Intensive property is independent of mass. For example, pressure, temperature, density. Extensive property is directly dependent on mass of the system. For example, internal energy, enthalpy, entropy. You are familiar with basic thermodynamics in your BA courses. The other definition is thermodynamic equilibrium. When we talk about equilibrium, it means that all the state of the matter is the same through the control mass or control volume. For example, when the system is on equilibrium with temperature, it means that in all the control volume or all the system, the temperature is equal or pressure. When a system is equilibrium for all the cases or all the states, it means that thermodynamic equilibrium. When pressure, temperature, chemical formula, phases is all the same in the control volume or control process, or control volume or control mass. The other definition is process. Process means that pass of the variation of one state. It means that from one state to other state. For example, consider cylinder and piston in the picture. There is a mass on the piston of the system. When you put heat into the system, the temperature of the system increases. Temperature of the system increases due to fix of the mass on the piston, so pressure is the same. Pressure don't variate it. But when you increase the temperature of the system, volume increases. Volume increases. So in the initial state of the system, we have one volume, defined volume, and as end of the process we have other volume. Volume is increases during the heating the system. So this is a process. Volume is variated from state 1 to state 2. The other definition is cycle. When we talk about a cycle, it's a process that in the end of the process we reach the initial state of the system. So the cycle is the several process after each other, and the end of the final process we reach the initial state of the system. The other definition is zero law of thermodynamics. Zero law of thermodynamics, but I put it as an example for you, as a question for you in the ballet group. Why zeroth law of thermodynamics? Zero law of thermodynamics is when two body are equal temperature with a third body. For example, system A, B and C. When A and B are in equal temperature, B and C are also in equal temperature, we can infer that the A and C system are in equilibrium or in equal temperature with each other. We can't infer that from the first law or third or second or third law of the thermodynamics. But why they select the zero? Okay, it's a question that I put it in the ballet group, and you can write it on the paper and submit it in the LMS site. The other definition is pure substance. The pure substance is a homogeneous and invariable chemical composition of material. It may be exist in more than one phases. So consider the liquid water in the cylinder and piston that you can see it in the picture. The first, it is a low temperature. So when we put heat into the system, the temperature of liquid water increases until it reaches to saturated temperature. When the water reaches to saturated temperature, more adding of heat to this water liquid causes the change phase of the material. So the liquid water convert to vapor water, and if we put more and more heat to this water, all the liquid water convert to vapor water. So in all the cases is the pure water, but in the first case is in the liquid phase, but in second phase are in vapor and liquid with each other, and in the third case is only vapor. We define the saturation temperature. Saturation temperature is defined as a temperature with vaporization at a fixed or defined pressure occurs. You are familiar with that with boiling temperature. We have the same saturation temperature and saturated liquid. This is a diagram of temperature versus volume of the water. We consider a fixed pressure. For example, B. In the case of B, the pressure of the water is 0.1 megapascal or 1 bar of pressure. So if we add a heat to the system, in the first part AB, the volume and temperature increases. But when we reach to the point B, So this in AB region we have subcooled liquid. That is a liquid that its temperature is lower than saturation temperature. So when we reach to the point B, adding more heat to the system cause the change phase of the water. Water convert from liquid to vapor. It's completely occur in BC. So if we put more and more heat to the water, the liquid water converts completely to the vapor at point C. After that, if we put more heat to the system, volume and temperature increases. That we are familiar with, that with saturation, superheated temperature. After saturated vapor in point C, in CD we have superheat vapor. Superheat vapor is a vapor that its pressure is the same as saturated pressure, but the temperature is more than saturated vapor. This is a face volume or contour volume, or that have three axes: pressure, volume and temperature. You can see the project of this diagram or contour on from T temperature versus pressure, TP diagram. You can see that several things. First, for all the matter, especially water, we have three phases. First solid, second liquid, and the third is vapor. We have a line between solid and liquid. That solid convert to liquid, and after that the liquid can convert to vapor. We have triple point definition. You are familiar with that. Triple point is a point that all the state of the matter, all the phases, solid, liquid and vapor, are exist in the same point. That is triple point. We have a critical point. Critical point is a point that is an inflection point of pressure versus volume diagram. Inflection point is a mathematical expression. Now, if we consider to this definition, after this pressure and temperature, the matter is continuously increase density. So we don't have a phases of a matter. All the phases are in the same shape of the matter. We have the thermodynamics table. We can review that with the book of that we use in the lesson. The book that we use in this course is some part of Van Wylen book, Fundamentals of Thermodynamics. The 8th edition is used in this course. So we talked about thermodynamics table. So in the appendix of the book table, for example B, table B1 and B2, we have the thermodynamics property of water: temperature, pressure, specific volume for liquid, vapor, and between of liquid and vapor. You can know familiar with that from the BA courses. So we have some example of this lesson that we know, review the thermodynamic table. The first example: determine the phase of each following water state using the table appendix B and indicate it in PV, TV, and PT diagram. The first case, the temperature is 120 degree centigrade and 500 kilopascal. So when we see it in table B, point 1.1, 120, you can see it in this section. When the water is in 120 temperature, the saturation pressure is 198.5 kilopascal. So when the pressure is 500 kilopascal, we go to the other table, B12. In B12 table, the first column is pressure and the second column is temperature. So if we consider to the 500 kilopascal, we see that the saturation temperature is 151.86 degrees centigrade. So the temperature is 151 degree. So the actual temperature is 120 degree centigrade. So the liquid is subcooled because its temperature, the pressure is pressure of saturated temperature, but its temperature is lower than saturated temperature. So the liquid is in subcooled region and it's a subcooled liquid. You can see it in the first diagram. The second case is that the temperature is 120 centigrade and the specific volume is 0.5 5 cubic meter per kilogram. So with the temperature of 120 degree, we back to the table B.1.1 and we search for 120 degree. When we are in 120 degree, the pressure is saturation temperature pressure is 198.5 kilopascal. But we search for a specific volume. Okay. $120. The specific volume is 0.5 cubic meter per kilogram. The saturated liquid has the specific volume of 0.201 and saturated vapor has 0.89. So the 0.5 is between 0.001 and 0.89. So the liquid is in two-phase region. The specific volume is between liquid and vapor. So in the second picture you can see it. And the water is in vapor and liquid phase, that's in the saturation temperature. Okay, this is the example and review of thermodynamics table. The other definition is that when we talk about the two-phase liquid, two-phase matter or two-phase water, some part of the volume is liquid and some part of it is vapor. So the total volume is equal to volume of liquid plus volume of vapor. Volume of liquid is equal to mass of the liquid cross a specific volume of water at the same temperature plus mass of the vapor cross multiplied by a specific volume of vapor. So if we want to determine a specific volume, we should divide volume by mass. You can see it, that is finally equal to a specific volume in two-phase region equal to a specific volume of liquid plus quantity that is defined as the quality cross nu Fg, means that a specific volume of vapor minus a specific volume of liquid. You can see it in the diagram. In this diagram, nu index of Fg equal to nu index G minus nu index F. So in the liquid state, the quality of X is 0, and in the state of the vapor, the quality of liquid is 1. The other example, a closed vessel contains zero point 0.1 cubic meter of saturated liquid and 0.9 cubic meter of saturated vapor of R134A as a refrigerant in equilibrium at 30 degree of centigrade. Determine the percent of vapor on the mass basis. So if we want the quality or percent of the vapor, we should determine the X in this correlation. So we can compute the mass of the liquid and mass of the vapor. So the quality of matter is determined at 0.221, means that 22% of matter is in vapor state. So the X is equal to 22. The other definition, the concept of pure substance is defined as when we talk about simple compressible pure substance, is defined in the absence of motion, gravity, surface forces, magnetic or electrical effect. All these effects can be affected the state of the matter. So in the absence of this, motion, gravity, surface and magnetic or electrical, the concept of pure substance or a state of pure substance is completely determined by two independent properties. We talked about the superheat temperature. The other example is that we talk about the first. The second is the question for you, and you can do it in the home with the book. Determine the phase of each following state of the matter. The first is ammonia in 30 degree and 1000 kilopascal. So if we want to solve this, we back to the B.1 table and we search for ammonia. The table B2 is for ammonia. The temperature is 30 degree. So when we search for 30 degree, we find 1167 kilopascal. So our pressure is 1000 kilopascal. So it's slightly less than temperature, but if we look for pressure 1000, we see that in the table 1030 kilopascal. The temperature is, saturated temperature is 25 degrees centigrade. So it's in the state of superheat. Its temperature is saturated temperature, but its temperature, that is 30 degree, is more than saturation temperature of 25 degree. For the second case, you can do it for homework in your home. So I put this exercise for you in the LMS site, and you can do it. I put the other lesson in the or other lecture in the for the next time is tomorrow. Tomorrow we continue this lesson from the compressibility factor. Okay, we ended this session, and to Saturday that we continue the lesson. Be successful.